this module, we are going to see how to apply the steps to formulate LPP to the given question. So let's start with our question. The question says that there is a company which manufactures two types of chemicals, chemical A and chemical B, which requires two types of raw materials, P and Q. Now the table gives some information about all this. That is, first row says that chemical A and B are there, and first column says there are two types of raw materials, raw material P and Q. Now it says, table says that for calculating or for manufacturing 1 unit of A, we require 3 units of P and 2 units of Q. Similarly, to calculate 1 unit of chemical B, we require 2 units of P and 5 units of Q. And obviously the last column indicates maximum availability of raw materials P and Q. Now let's see what is the next information given. Next, they have said that the company gets profit of rupees 350 by selling 1 unit of A and profit of rupees 400 by selling 1 unit of B. And we have to calculate how many number of units of chemical A and chemical B this company should manufacture in order to achieve maximum profit. So we have to formulate all this information as LPP. So let's apply the steps we had studied earlier. So step 1, that is finding out decision variables. Now it is given that the company manufactures two types of chemicals, A and B. So problem here is to determine number of units of chemical A and number of units of chemical B. So remember students, these are the quantities to be determined. That is number of units of chemical A and chemical B. So that will be our decision variables. So let's denote them by X and Y. So let X units of chemicals A and Y units of chemical B should be manufactured by the company. Now these are our decision variables, that is X and Y. Next we will calculate something called as objective function. It is given that company gets profit of rupees 350 on 1 unit of chemical A. So obviously on X unit of chemical A, company will get 350x rupees profit. Similarly, for on 1 unit of chemical B, company gets profit of rupees 400. So on Y units of chemical B, company will make profit of rupees 400 multiplied by Y. So total profit made by this company will be 350x plus 400y. So let's denote this capital letter Z, and this is our required objective function. Now we'll go for next step, that is calculating constraints. So let's see the given table. The given table says to calculate 1 unit of chemical A, we require 3 units of chemical B. So obviously to calculate 1 unit of A, we require 3 units of P. So obviously to calculate X units of A, we require 3x units of P. And similarly to calculate 1 unit of Y, the company requires 2 into Y units of P. So total amount of raw material P required will be 3x plus 2y. Similarly, to calculate 1 unit of A, we require 2 into x units of Q, and to calculate y units of B, we require 5 into y units of Q. So total amount of Q required will be 2x plus 5y. And since the last column says the maximum availability of raw materials, therefore we should use less than or equal to sign here. So let's use less than or equal to inequality. Now maximum availability of P is given as 120. So our first constraint will become 3x plus 2y must be less than or equal to 120. And second constraint will be, since maximum availability of Q is given as 160, so 2x plus 5y must be less than or equal to 160. So these two will be our constraints, required constraints. So after this, last step is remaining, that is calculating any hidden conditions, that is non-negativity restrictions. We know that unit of production cannot be negative. So company always manufactures positive number of chemical A or B, or at least 0 units. So obviously X and Y must be greater or equal to 0. These are our non-negativity restrictions. And with all this, combining all this, our problem can be formulated as Z equal to 350X plus 400Y. And since it is profit, we need to maximize this. So maximize Z equal to 350X plus 400Y subject to the given constraints, that are 3X plus 2Y must be less than or equal to 120 and 2X plus 5Y must be less than or equal to 160, and X and Y are greater than or equal to 0. So this is the required answer for formulation of LPP. With this, we'll conclude our module. Thank you.